You are completely wrong about gravity. You probably think you understand it because you've dropped things your entire life. You see an apple fall, you feel your weight on the floor, and you think, that's gravity, it's pulling me down. But here's the problem with that beautiful, simple idea. Gravity doesn't pull, it never has. And if you think you have a good grip on how gravity works, just because you can feel your feet on the ground, you are in for a very rude awakening. Right now, as you sit in your chair, you think you're stationary. You think gravity is holding you down, like an invisible hand pressing on your shoulders. But that's not what's happening. You are not being pulled. You are not being held. You are falling. You have been falling your entire life, and the only reason you don't notice is because the floor keeps getting in the way. Let's start with what goes on inside your own body, because that's where the confusion begins. Stand up right now. Feel your weight. Feel the pressure on the soles of your feet. What are you feeling? You think it's gravity pulling you down. Wrong. What you're feeling is the floor pushing up. That sensation, that pressure, that weight you experience every single day is not gravity. It's electromagnetic repulsion. The atoms in your feet and the atoms in the floor are screaming at each other. Don't touch me! They're shoving against each other with incredible force. That's what you feel. Here's a simple experiment. Press your hand flat against a table. Push hard. Feel that resistance? That's not the table being solid. That's electrons in your hand repelling electrons in the table. The nuclei of atoms never actually touch. They're surrounded by clouds of negative charge, and those clouds hate each other. They push back. Now, remove the table. Just drop your hand through the air. What do you feel? Nothing. No pressure. No weight. But gravity is still there, isn't it? So why don't you feel it? Because gravity doesn't push or pull in the way you imagine. Gravity is not a force pressing down on you like a weighted blanket. When you're in free fall, when nothing is stopping you, you feel nothing. Astronauts in the space station aren't floating because there's no gravity up there. They're falling. The station is falling. The moon is falling around the Earth. They just keep missing the ground. Think about a roller coaster. You know that moment at the top of the first drop when your stomach lurches? That instant when you feel weightless? That's not because gravity stopped. That's because the seat stopped pushing you. For one brief, perfect moment, you are in free fall. You are experiencing what gravity actually feels like. It feels like nothing. Let's try something. Close your eyes and imagine you're falling. Just falling. Not hitting the ground, not scared, just falling forever through empty space. What do you feel? Some of you will immediately clench up. Your body tenses. You imagine wind rushing past your face, your stomach dropping, panic rising. But that's not gravity. That's your inner ear detecting acceleration. That's air resistance. That's biological programming from a million years of not wanting to die. Others will imagine serenity, floating, drifting, like being underwater but without the water. You might even feel peaceful. Here's the problem. You're both wrong. Free fall doesn't feel like anything, because when you're falling, you're not accelerating relative to yourself. Every atom in your body is falling at the same rate. There's no internal stress, no stretching, no squishing. This reveals something fundamental. What you experience as the pull of gravity is entirely a mental construct. It varies wildly from person to person. It is not a universal constant. It is a biological hallucination manufactured by your nervous system to keep you from walking off cliffs. So when we talk about physics, when we talk about the universe, we have to throw your nervous system out the window. We have to stop talking about how gravity feels and start talking about what it actually is. In physics, we have to be operational. We don't ask, what is the essence of gravity? Because that's a question for philosophers who enjoy arguing over coffee. We ask, how do we measure it and what does it predict? And the answer is going to sound insane. Gravity is not a force. Gravity is geometry. Imagine you're standing on a perfectly flat trampoline. You can walk in any direction in a straight line. Now someone drops a bowling ball in the middle. The trampoline sags. It curves. Now when you try to walk in a straight line, you can't. You spiral inward toward the bowling ball, not because it's pulling you, but because the surface itself is curved. You're still walking straight. The ground just isn't flat anymore. This is what mass does to space. Earth is not pulling you down. Earth is bending space around it. You are trying to move in a straight line through time, just existing, and that straight line happens to curve toward the center of the Earth because Earth has bent the fabric of space-time itself. You are not being pulled. You are following the curvature. Let me say that again because it's the most important sentence in this video. You are not being pulled. You are following the geometry of space-time. This is Einstein's General Relativity, and it completely destroys the Newtonian idea of gravity as a force. Newton said, "There's an invisible rope between you and the Earth, and it pulls." Einstein said, "There's no rope. The Earth warped the map, and you're walking on a curved surface. When you drop an apple, the apple is not being yanked downward. The apple is moving in a straight line through four-dimensional space-time, and that straight line happens to intersect with the surface of the Earth because Earth carved a dent in the universe. This brings us to the biggest mistake everyone makes. You think you are stationary right now. You think you're sitting still and gravity is a force acting on you to hold you down. Wrong. You are trying to fall. You are trying to move along your natural path through space-time, which curves toward the center of the Earth. But the floor is in the way. The floor is shoving you. The floor is accelerating you upward, away from your natural trajectory. You are not at rest. The floor is constantly pushing you, and that's why you feel weight. Here's where it gets truly bizarre. If you were in a windowless elevator in deep space, far from any planet or star, and the elevator started accelerating upward at 9.8 meters per second squared, you would feel exactly the same as you do right now sitting in your chair. You would feel weight. You would feel the floor pressing against your feet. You could drop a ball and it would fall to the floor. But there's no planet. There's no mass curving space. There's just the elevator accelerating. Now flip it. Put that same elevator near Earth and cut the cable. Let it fall. Inside the elevator, you would float. You could push off one wall and drift to the other. You could juggle water droplets. You would feel weightless. But Earth is right there. The mass is curving space. So where did gravity go? It didn't go anywhere. You're finally experiencing what gravity actually is. You're in free fall. You're following your natural path through curved space-time, and nothing is pushing you off that path. This is why Einstein called it the equivalence principle. You cannot tell the difference between being in free fall in a gravitational field and being in deep space with no gravity at all. They are the same thing. Gravity is the absence of feeling, not the presence of force. When you feel weight, you are being pushed. When you feel weightless, you are in your natural state, following the curvature of space-time. This destroys your intuition. It feels backward. But that's because you've spent your entire life on a surface that won't let you fall. You've been pushed your whole life, and you thought that pushing was normal. Let's go bigger. You are sitting on Earth. Earth is moving through space, but Earth is also falling. The sun has bent space-time around it, carving a deep well. Earth is moving in what it thinks is a straight line, but that line curves around the sun because space itself is curved. Earth is in free fall around the sun. It just keeps missing. The moon is in free fall around Earth. The space station is in free fall around Earth. Satellites are in free fall. They're not held up by anything. They're falling, and they're moving sideways, fast enough that by the time they fall, Earth has curved away beneath them. This is orbit. Orbit is not floating. Orbit is not anti-gravity. Orbit is falling and missing the ground forever. And here's the truly disturbing part. You, right now, are also falling around the sun. Earth is dragging you with it. You are plummeting through space at 30 kilometers per second, carving a curved path through the warped fabric of space-time. You just don't feel it because everything around you is falling at the same rate. If the sun suddenly vanished, space-time would flatten out. Earth would stop curving and fly off in a straight line, carrying you with it into the void. You wouldn't feel a thing. No jolt, no change. You'd just suddenly be moving in a straight line instead of an ellipse. Gravity is not a tether, it's a map, and you're a marble rolling on a curved surface. Let's go back to that experiment. Imagine falling. Some of you pictured wind and terror, some pictured floating, but none of you pictured the truth, which is that free fall is the most natural state of existence, and it feels like absolutely nothing. This tells us something fundamental about human cognition. We are not built to understand the universe, we are built to survive on a planet. Our brains evolved in an environment where falling meant danger, where weight meant safety, where up and down were absolute directions. But the universe doesn't care about up and down. There is no up, there is no down. There is only the shape of space-time and the paths objects follow through it. When you try to explain general relativity to someone, you're not just teaching them new information, you're asking them to uninstall their entire operating system. You're asking them to accept that their most basic sensory experience, the feeling of standing on solid ground, is a lie. Not a lie in the sense that it's fake, but a lie in the sense that it's a translation. It's your brain converting the complex, four-dimensional geometry of curved spacetime into a simple, three-dimensional sensation of down. You don't feel the curvature of space, you feel the electromagnetic repulsion of atoms. Your brain labels this weight and invents a story about gravity pulling you. It's efficient, it keeps you alive, but it's not true. This is why physics is hard. This is why it feels like we're speaking a foreign language. We're not just giving you new facts, we're asking you to see through the illusion your brain has been manufacturing since birth. So what is gravity? Gravity is the curvature of space-time caused by mass and energy. Gravity is the straightest possible path through a bent universe. Gravity is the reason you age slower on a mountain than in a valley, because time itself flows at different rates depending on how deep you are in the gravitational well. But most importantly, gravity is the mirror. It reflects the limitations of your own biology. When you feel your weight, you are not feeling gravity. You are feeling the floor pushing you away from your natural path. When you drop something, it is not being pulled down. It is following the shape of space carved by Earth. And when you stand at the edge of a cliff and feel that primal fear of falling, you are not afraid of gravity. You are afraid of the ground. Because gravity is what happens when nothing stops you. Gravity is freedom. Gravity is the universe letting you move naturally. The ground is the enemy. The ground is what breaks bones. The ground is what interrupts your perfect, weightless trajectory through space-time. If this makes your head hurt, good. That means the translation scheme is breaking down. That means you're starting to see the cracks in the wall of common sense. Don't be afraid of the confusion. In science, confusion is not a dead end. It is the starting line. It means you are about to discard a comfortable lie for a difficult truth. This is what Einstein saw in 1907 when he imagined a man falling from a roof. That man, Einstein realized, wouldn't feel his weight. He would feel nothing. That simple thought, that one image of a falling man experiencing weightlessness, destroyed 200 years of Newtonian physics and gave us a new universe. It was, in Einstein's own words, the happiest thought of my life. And it led him to this. Gravity is not a force. Space and time are not separate. Mass tells space how to curve, and curved space tells matter how to move. Everything you thought was solid, everything you thought was pulling, is just geometry, just shape. just the natural flow of objects through a bent cosmos. Gravity does not pull, it never did. And the fact that we little biological machines, made of stardust and anxiety, can figure this out, that we can see past our own nervous system and glimpse the actual geometry of the cosmos, that is the greatest wonder of all. You have been falling your entire life. Einstein showed us why. The only question is, are you ready to stop fighting it?